L'Hopital's rule is invaluable in finding limits. It says that if f and g are differentiable on an open interval, except possibly at a point c, and g prime is not 0 for any of the x in ab, except possibly at c, then the limit as x approaches c of that quotient is going to be the same as the limit as x approaches c of the derivative of the quotient, or the quotient of the derivatives. So, provided the limits exist, or if they're might even be infinite. Now, even if x approaches infinity, we can use this. If c goes to infinity and the limit as x approaches infinity of f over x is infinity over infinity or 0 over 0, then we can look at the ratio of the derivatives. Now, before we go on, we have to check. So if I'm looking at the limit as x goes to 0 of e to the x over x, as I put in 0, this is going to be e to the 0 over 0. So this is 1 over 0. And so this does not exist. And I can tell that by looking at the graph. That as x approaches 0 from the right, the limit is positive infinity, while as x approaches 0 from the left, it's negative infinity. I can't just go, oh, it's L'Hopital's unit, so I'm just going to take the derivative and get the limit of 1. So make sure you check. So let's look at this one right here. The limit as x goes to 0 of e to the 2x minus 1 over x. We've done this one, but the first thing I'm going to do is plug in. So this is e to the 0 minus 1 over 0, which is 1 minus 1 over 0. It is indeterminate. It is 0 over 0. So I can use L'Hopital. So I'm going to break this up painfully for you. F of x is e to the 2x minus 1. So f prime of x is 2e to the 2x. G of x is x. So g prime of x is 1. So this becomes the limit as x approaches 0 of 2e to the 2x divided by 1. When I plug 0 in, I just get 2e to the 0, or 2. Now, it's possible you get infinity over infinity. If I plug in infinity, then if I take the limit as x approaches infinity, this becomes infinity over infinity. It's indeterminate. Can't do it. So I need to use L'Hopital. So I'm going to let f of x equal the natural log of x. G of x is equal to x. F prime of x is 1 over x. G prime of x is 1. So this limit becomes the limit as x approaches infinity of f prime, which is 1 over x, divided by g prime, which is 1. So this limit is 0. Now you may need to apply L'Hopital more than once, and that's okay. As x approaches negative infinity, this goes to positive infinity, and this goes to positive infinity as well. All right. We know we can apply L'Hopital, so I'm going to let f equal x squared, and g equal e to the negative x. So f prime is 2x, g prime is minus e to the minus x. So when I plug this in, it becomes the limit as x approaches negative infinity of 2x divided by, and we're just going to pull that minus sign out here, e to the minus x, which again is, the negative sign is kind of irrelevant here. I'm going to pull it out. So this is minus infinity divided by infinity. So basically it's indeterminate. IND. Sorry about that. Pin's messing up. So I'm going to try again. This time I'm going to let f equal 2x. And yes, you can come right up here and do it again. That's fine. You don't have to do it the way as detailed as I am. Okay, so f prime is 2, g prime is e to the x. So this becomes the limit as x approaches infinity of 2 divided by e to the negative x. I lost my negative signs there. And I see that this becomes infinite, 2 over infinity, so that's just 0.